Assalamualaikum and a very good morning to you all. Today we are going to do an example on the shaft design. Okay, this example is taken from chapter 7 from the book Shigley Mechanical Engineering Design. Okay, student are encouraged to have the book beside you because when you are doing this calculation, you will refer to some facts from this book. Okay. Um, okay, the example at 7.1. At a machine shaft shoulder, the small diameter is D is 1.1, the largest diameter D is 1.65 inch, the fillet radius is 0.11 inch, the bending moment is 1260 pound per inch, and the distortion moment is 1100 pound per inch. The heat treated steel shaft has ultimate strength of 105 kpsi and yield strength of 82 kpsi. The reliability reliability goal for endurance limit is 0.99. So the question wants you to calculate the fatigue factor of safety of design for each of the fatigue failure criteria and determine the yielding factor of safety. You remember in the last video I tell you about distortion energy, Soderberg, Goodman, SME, epileptic, and that's all. This is all you have to calculate in this calculation. So I encourage you to have the pen and calculator beside you. Okay, and this is what you are going to calculate. This is what the can imagine from the question. This is a shaft. This is a small shaft. This is a small diameter. This is a larger diameter for the shaft. Okay, imagine this is what you want to calculate. Okay, the first thing you want to learn about any calculation is you have to imagine what you want to calculate. If you don't have that imagination, it is difficult because you do not know what you want to calculate. Okay. Okay, student, the first thing you have to do is to calculate the ratio for large diameter over the small diameter. 1.65 of divided by 1.1, you get 1.5. uh, the the ratio for radial fillet divided by small diameter 0.11 divided by 1.1. It is all given in the question. And then stress concentration factor you get from figure A59. This is figure A59. It is the uh, round shaft with shoulder fillet in bending. In bending. Okay, the stress concentration factor in bending. Okay, I am bending this my cardboard here representing the shaft, and then the stress concentration factor from uh, figure A15.8 for torsion. If torsion is given like this, so you get from the table. I suggest you to have the textbook. um, get from the table. From the ratio is you this is the ratio you calculated before. Okay, this is also the ratio you calculated before, and then you tabulize and you get this figure 1.42 and also 1.68. Okay, and then you another thing is the noise sensitivity factor for shear and for bending. Okay, you get from for bending is 6.20 and for shear is 6.21. Okay, what is a notch sensitivity? Okay, see I draw here in the shaft. Represent a shaft when something sharp hitting the surface. Okay, it depends on the material of the surface. Then it will become notch. This is a notch. Okay, if the material is brittle, it break easily. This material is hard, it break not easily broken. Okay, but all the crack propagation happen at the notch. Then it will propagate and it will break. Okay. So from the equation 6.32, okay, given in the chapter 6, okay, this here is the equation 6.32 over here. Okay, it stated Kf, crash concentration factor Kf equals to 1 plus Q Kt minus 1, and stress concentration factor for torsion. Okay, for shearing is 1 plus Q shear K Ts minus 1. Okay, apply to this equation. Okay, for this equation, you get Kf equals to 0.85 plus 0.68 minus 1 equals to 1.58. And also you get KFS 1 plus 0.88, 1.42 minus 1 equals to 1.37. You get this value from the previous slide, okay, from the stress concentration factor. Also this value from the previous calculation, you get 1.68, 1.9. And then the important thing is you want to get the stress concentration factor, okay, for shear and for bending. Okay, now we calculate the endurance strength. Okay, so endurance strength we get from the equation from page 290. Here from page 290, you get the ultimate strength. They have three options for ultimate strength: 0.5 as 0.5 SUT, 100 kpsi, and to 700 megapascal. Okay, since given from the question is 105 kpsi, which is the value is here. This is the option. Okay, you put in the equation 0.5 times 105, you get 52.5 kpsi. Okay, this is how you do this question. Okay, now students, we want to calculate the surface modification factor. Ka stand for surface modification factor. Okay, so from surface endurance, Se equals to Ka, Kb, Kc, Kd, Ke, Kf, and Se. Okay, we will learn all this in the next slide. Okay, so Ka, which is stand for surface modification factors, equals to A SUTB. Okay, SUT is the ultimate strength. A is the factor A you get from machine or cauldron, because the example, the question says that the shaft is made from steel. It's made from steel shaft. Okay, so that is why we select 2.7 as A, and the exponent B is to 0.265. You put in the equation, and ultimate strength is 105. You take the calculator and you calculate, you get the value. You get this value 0.787. Now we want to calculate the KB, which is the size modification factor. It comes from the equation as E surface endurance equals to Ka, Kb, Kc, Kd, Ke, Kf, and surface endurance. Okay. So what does it mean, Kb, Ka, Kb, Kc, and everything? So Ka is the surface condition modification factor. Kb is size modification factor. Kc is load modification factor. Kd is temperature modification factor. Ke is reliability factor. Kf is motionless effects modification factor. SE is rotary beam test specimen endurance limit SE prime, and SE is endurance limit at critical location of a machine part or condition being used. Okay, so given from the question, the diameter is within this range 0.01 and 2 inching. It is within from this range, so you use this equation d over 0.3, 0.879. This you use from this equation, you get from this equation 1.1. Okay, from question, you put 1.1 divided by 0.3, the power of negative 107, and you get the value 0.87. Okay, you get this value. Okay, now we are going to get the reliability factor KE. KE, from the question, it is given that reliability is 0.99, which is 99%. Okay, this is 99% given from the question. So KE is here. Okay, reliability factor from the table 6.5. Okay, this from this table 6.5, you get KE equals to 0.814. Okay, ultimately we want to find the surface endurance. So in order to get the surface endurance, you have to get all this value. So from the previous calculation, you get the value for KA, which is 0.787, KB 0.87, KE 0.814, and SE surface endurance 52.5. You put all this value and you calculate, and you get the value for surface endurance is 29.3 kpsi. Okay, and what are the other values? The other values are 1. That is why when you calculate in the previous slide, you see that other values are considered as 1. Okay, the alternating moment is given in the question as 1260 pound inch, and the torque, mid-range torque, is given by 1100 pounds inch, and mid-range moment and alternating torque equals to 0. What does it mean? It means from the question, this is the original question given. You have to imagine this. This is what you want to calculate. For the purpose of clarification and for your understanding, what is the meaning by moment, mid-range moment is 0 and alternating torque is 0. Okay, it means that the shaft is not moving. The shaft is static like this. Okay, it's not moving at all. No alternating torque like torsion, like this. No alternating torque, and also the mid-range moment is 0 because it has this. It has this what they call the fillet like this lah. It's because it have the shoulder. Okay, so the shoulder, it prevents it from uh, becoming a moment. Okay, students, you want to get the fatigue factor according to the DA Goodman. After this, you have to calculate for all the values. Okay, for given for the first one, calculate for the DA Goodman, distortion energy Goodman. You want to know about the fatigue factor N. Okay, this is the equation from DE Goodman given by equation 7.7. Okay, all the value you have already get from your calculation before, you get the surface endurance value. Here, this is the surface endurance value, SE. Is this 105,000 ni you get from the from the question. Okay, this is given diameter 1.1. This is the stress concentration factor you get from the table. Okay, this is also you get from the table, stress concentration factor. Okay, this is you get from given from the question. Okay, this is the given from the question, this value, alternating stress, and also the value for alternating torsion. Okay, given, and you put everything, you get the value. 1 over n is 0.615, and you get the n value is for the equipment is what is the value 6 point something. Okay, so applying the same for Gerber, SME, epileptic, Sonderberg, you get the value quite different value, but this is the what the question one. The question want you to calculate the fatigue factor for all the Goodman, Gerber, SME, epileptic, and Sonderberg. You just put all your values you get in the equation, and then you get the value. Okay, that's all, and you have answer for question A. Okay, students, this is when you want to compare whether your result is correct or not correct. Okay, you use the equivalent approach. Okay, this is the equivalent approach. Use the equation 7.5 and 7.6. This is the equation. If you see this equation, do you familiarize with it? It represents the theorem Pythagoras. You remember when your mathematics class, the theorem Pythagoras, AB equals to square root of A power 2 plus B power 2. Get this theorem Pythagoras. The equivalent value, this is the value that you get from theorem Pythagoras. Okay, then you get this value. You 155, you calculate and you put again this value. Okay, you put again this value 1.37 from stress concentration factor. This value is given from the question, and you get the Goodman value and everything you get from this equation. So the Goodman as epileptic, and you get the same value as before. Okay, this is how you check whether your calculation is correct or not correct. Okay, now we are going to calculate the yielding factor of safety. Okay, this equation is given by SY, yield strength, okay, divide by stress, maximum stress. You get 82,000 is given from the question. It's given from the question, 82,000, and this you calculate from this equation, stress maximum. You get from this equation and get 18,000. Okay, you divide by everything and you get the value 4.5. Okay, this is the value 4.5. Okay, so what is actually a factor of safety? Okay, remember this shaft. Okay, this cardboard I represent a shaft. Okay, what make it fail? If you calculate, you get this equation. Get the factor, and what make it doesn't yielding is like this. Okay, meaning that somehow this is what you clamp, and then it broke, it bent away like this. At this point is become yielding. At this point it become yielding. Okay, this point it become yielding. So we want to avoid yielding. So the factor of safety given by we calculate and we get 4.5, meaning that for all the calculation given you want to get the diameter, the good diameter for your shaft, you go times with the factor of safety, then you get the diameter, and then you can be sure your shaft is safe from failure. Okay, and then for comparison, a quick and very conservative check on yielding can be obtained by replacing stress maximum with alternating stress plus median stress, and uh, you get the equation from this, and then you get 15235 is given in the previous slide, plus 9988 also from the previous slide. You get 3.25, meaning that to save the calculation time you get this value 3.25, and quite conservative compared to the value you get before 4.5. So what is the meaning by conservative value 3.25 versus conservative value with the calculated value 4.5, meaning that in normal value people use traditionally as a factor of safety is 3.25. Okay, you can use this value. Also, if you calculate, you get 4.5. It is safer. It's safer to use 4.5 in your subsequent calculation to get the diameter for the shaft. Okay, the diameter for the shaft. This is important for the diameter of the shaft. It is okay to use 3.25. You get a quite smaller diameter, and you get for 4.5 you get the much bigger diameter. That is what it means by this. Okay. Okay, students, never fear. You have some websites to help you. Both are helpful. They are the Mathway. This Mathway website. This is the Mathway. You can download the apps in your smartphone, and also this is the Wolfram Alpha, another website better to use in your laptop. The way I use is I type in Mathway and I copy and paste in Wolfram Alpha. It is helpful to you when you doing exercise. But of course, in your final examination, you cannot bring your laptop. You just have to bring your calculator with you. But both, uh, when you exercise time, you do with the website. When your exam time, you use your calculator. Okay. So that's all for calculation. It's a very lengthy video. It's 20 minutes. So for the next video, we'll discuss you about estimating stress concentration. Okay. Thank you very much.